Hello, welcome to this new, possibly final video on making snooker or pool or billiards in JavaScript using the P5 library. So as you can see, I've made a few changes since that last video. I think it was like video 5 or something like that, where we'd finished with oh yeah, I've just sorry, I've just shown my snooker skills there and potted the cue ball. So this is running not too slowly, even though I'm kind of screen recording now. Um, this what was I going to say? This oh yeah, a few changes we've made. We've got ball physics going on. You saw the cue kind of mechanism, which I don't think I'll have time to talk about in this video. What's the time? Okay, I'll keep this to about 15 minutes. But I just wanted to explain the ball physics. Maybe you were interested in making a similar kind of game, or something that involves lots of collisions, and you wanted to know how do you get balls to, particularly snooker balls, to hit one another and then go off in the right direction. And I had to do some research, so I'd never looked into this kind of maths to work out how to do it. Right, so let's I don't know, have an experiment. Let's watch very closely. So I'm going to attempt to hit this pink ball here, and I'm going to hit it with a bit of an angle. So if I hit it at this kind of an angle, oh, I can't really demonstrate it. Right, this kind of an angle about there, then hopefully it'll move upwards. And of course, if I hit it at this side, it will go downwards. Right, I'm going to try and hit it so that the pink ball goes upwards. Here we go. Okay, I hit it kind of dead on. Let's try again. Let's hit, right. I'm going to try this pink ball here, very, very close. So again, I'm going to hit it at quite an angle. We should see it. Lovely. It moves off at the correct kind of vector, the correct direction. So talking of vectors, let's close him down and bring up the research. Here we go. I found this diagram, physics of billiards, and also a problem of finding a perpendicular vector we'll look at. So basically, in our ball collision function, what we want to do is check basically if the balls are overlapping first of all. So we've got contact. So a ball, it has now moved to a position where it's making contact. I'm making a fist. I don't know why, I'm getting serious. We've got a mathematical diagram. I've got a fist. It's quite late at night. What was I saying? So, what this diagram beautifully shows you is that one of the balls, the kind of like, let's call it the incident ball, because it's creating this collision incident, it's going to move off perpendicular to the vector that joins its position center and the other ball's center. So we know we want to create a vector between, and this is quite an easy thing to do. We can just say the vector is my position xy, the other ball's position xy, and we're already kind of drawing that, creating that vector anyway when we're checking to see if the billiard balls are close enough together, because we're measuring this vector's magnitude. Anyway, so then all we need to do is calculate the perpendicular vector, make sure it's facing this way, not that way, and say your new direction is following that vector. Let's look at the other ball. The other ball, very easy, its vector is just parallel to that, what should we call it, like collision vector, we'll call it. Okay, so let's have a look at the code. So here we are. Where are we? We are in check collision function. And before I just had like a placeholder. It was kind of fortuitous. I just basically swapped the ball when the balls hit. I just swapped their vectors, I think, or velocities. So this time we're doing something a bit more sophisticated, but it's only a few lines. What is it? I don't know, 20 lines, something like that. And a lot of it is taken up by just entering vectors in and stuff. So firstly, what does this do? We say let distance equal, and we're asking for a new vector where we subtract this vector, and it's a position, from this vector. So let's use a diagram. So basically I'm saying this position minus this position gives us this vector. So that's our, what do we call it, our collision vector. Okay. And then I'm asking for its magnitude, so that's how long it is. And then we're saying if that distance, if that magnitude, sorry, is less or equal to both of the ball's radii, then they must be overlapping. That's fairly similar to what we had before. Then, I've called this like a private joke, Pauli exclusion. Basically, I'm asking now for this position, sorry, the incidental ball, the ball that's doing the damage or introducing the collision. We're now moving it backwards along that vector, that distance vector, a tiny amount. A tiny amount. And let me just show you why. There we go. So we're saying this distance is less or equal to this radius plus this radius. So basically the balls are overlapping. Now, if they're overlapping, that's physically impossible. You can't have two physical objects occupying the same space. So all that subtraction does is move this ball, this is our incidental ball, it subtracts it back along the collision vector until they're no longer overlapping, because we can't get in here, we can't get in this bit, which is where that subtraction, that kind of backsliding happens, unless the balls are overlapping. So it won't keep sliding back if they're not touching. Okay, so the first thing we do is just make sure that the balls aren't overlapping anymore. If you don't do that, you'll get horrible. I think I put a video on Twitter if you're interested. I had the balls kind of overlapping, and then they kind of like span out of control like photons and neutrons and crazy stuff. So make sure the balls aren't overlapping. Now we're almost finished there. How are we doing for time? Not bad, 7 minutes ish. So now I'm saying I've got a new distance here, and I put an underscore. You might have a few problems. I'm not very familiar with how P5 like organizes and keeps control of its vector object. So sometimes I was multiplying or subtracting vectors, thinking I was just dealing with the value, but actually it was affecting that object for all subsequent calculations. So I was doing something to it when I thought I wasn't, trying to use it again, and it wasn't the same thing anymore. So anyway, I'm making a new vector to keep things clean. And what is this vector of? It is this position, so the incidental ball's position, minus the kind of like the passive ball's position. So that's the opposite to what we had before. Let me show you. So we've just done this position minus this position, which gives us this heading. Now we want to find this kind of direction, and we already know this direction. So this direction and this direction. And hopefully the code will reflect me applying this to one of the balls and this direction to another of the balls. How do we do that? We do that in the following way. First we do this step, normalize. That just means I want to take away all of the magnitude and everything. I just want the pure heading. Because if you don't take away all the magnitude and you try and apply this heading, you're not just applying a direction, you're applying like a large number, and you'll have the balls flying out towards I don't know. Pick your favorite space station. It's going to go over there. And then what we're doing? So we've just purified the vector, so it's just a direction. And now I'm making a new vector. And I'm doing a little calculation. I'm saying I want to make a new vector out of the properties, the components of that new heading. And I'm saying I want the y I put the y component in the x position, and the x position in the y position, and I've minused the y vector. Why have I done that? Well, it's in order to calculate this guy. So I need to know which way our incidental ball is going to go. It's going to go perpendicular to this heading. And how do you do that? You do it by finding the perpendicular to the vector. So a vector perpendicular to AB, so x and y, is minus b minus y x. So you just swap the x and the y and minus the y. Does that make sense? So back to the code. I've said, so I found, firstly I found the heading vector, which is, our collision vector, this one. Find that. And then, so that's called underscore dist. Normalize it, make sure it's just about direction. And then minus its x component, leave minus the y component, leave the x component as it is, but put it in the y place. And then normalize that again. That should all be normalized, but normalize it again because I'm paranoid about vectors. I don't know. Right. Then we want to add that to the ball, and interestingly enough, I've just added it to one of the balls. I found what works for me is just adding that perpendicular vector to this incidental ball. This, it it seems to just work. It must be picked up. Maybe it has its own, when we iterate over all of the balls, it does the same calculation but in the opposite position and it moves off fine. Anyway, that seemed to work. So my tip is just to apply it to one, maybe try it to another one. So what I've done is say, so that crucial, wait a minute, no I haven't. Look, I've actually added the original distance. So actually that perpendicular vector isn't being added at all. I've just added the original distance one. That's interesting. So sorry, all I'm doing, I'm just reading back my code. It looks like in a previous version of my code, which I've left in, I've calculated this perpendicular thing and added it to, and it hasn't worked as well. So all I'm doing is calculating. I'm not calculating anything. I'm just finding the heading and applying that to to this ball. That's interesting. I don't know what is going on there. Anyway, and what am I then? Sorry, I've just explained a load of stuff and it didn't even really apply. Must work somehow. How am I doing that? Anyway, then if two balls have hit, you hear a sound, so they're losing some energy. So I've reduced their velocities. I've just slowed them down instantaneously. So I've multiplied each of their velocities, the incidental ball and the ball that we're hitting, by amounts, and I've kind of fine-tuned it, and this seems okay. And then we've multiplied that heading, this guy, by 0.6 times v-store. V-store is the magnitude of the velocity of this ball. So we're looking at how fast it's going. Sorry, it should be this ball. I see what's going on, sorry, this ball is the opposite to what I was saying. That ball is this one. And the underscore B ball is our incidental one. That's what's going on. So we're recording the incidental ball's speed times and applying that to the other ball. So we're using that relevant value of its velocity and adding it to the original ball. Right, to the other ball. And what am I adding? I'm, instead of just swapping velocities or applying velocity, I'm doing what a physics engine should do. Is when you want to change something in a physics engine, you should apply force. And in terms of we did some like Euler integration. We've got acceleration. Now, acceleration means force in this little system. So we could add velocity, and we'd have an effect, and it might look pretty good. But we're adding to the acceleration. So this is a vector, and the add function is a function of the P5 vector object. And I've been through what amount. So I'm not just leaving that as it's. So that's just a normalized direction, and we're multiplying it by a certain amount. Right. So that's that working. Let's just have a look at him again. So what I'm really interested in is the fact that my code here is working. This is pretty realistic reactions. They're jumping a little bit, I've noticed, when I've got this screen recording going on. But in terms of their directions and everything, it's pretty good in terms of real life. Right. So let's see what happens when we do what would make sense. So our incidental ball, this guy, sorry, this is our incidental one, underscore B. When it hits, when it's overlapping, it should go off at the perpendicular, which is happening automatically somehow. I don't know how that's happening. So B, acceleration, add. So we're going to add to its acceleration. And let's just add the normalized NV. So NV was the new vector, and that's the perpendicular vector. So I don't know if I've got it facing the right way. What am I doing? Oh, NV, sorry. NV, that's it, right. Let's just see what happens. So we should either get balls going at very strange angles, and then I'll try just minusing the value. Okay, all angles are correct. Oh, or are they? Yeah, that looks a bit better. Actually, oh no, there's some funny business going on. There is some funny business going on. It didn't look as bad as I anticipated. I anticipated we'd get the wrong polarity there for our perpendicular vector. Let's try them again. Okay, that looked pretty good. Okay, no funny business this time. Oh, lovely, right. So now we're properly applying both forces. We want to apply force to the ball we're hitting, and then that, I don't know why I keep calling it the incidental ball that's flying in. So this is pretty good. So, brilliant. Right, let's, how long has this been? 18 minutes, wow. Let's add, sorry, let's just multiply, let's just reduce this down by the same amount. So this number, this v store, remember, was the velocity that the incidental ball arrives at when it makes contact. And I had to fine tune the amount, 0.6. So again, I'm not really understanding my own code and working out as much as possible, as much as I should do. But if I've got two balls involved, that kind of velocity coming in needs to be split in half, else we're creating energy from nowhere, if you see what I mean. 0.6 is over half. So we might get balls kind of accelerating faster than they should do. It might be more energy in the system than is allowed. It didn't look too bad, to be honest. Yeah, they kind of feel a little bit like they've got too much momentum or something. That's pretty nice. Anyway, let's I don't know. Let's just reduce this to 0.5. We're almost. I think this is pretty much the end of the video. So I've explained how to calculate perpendicular vector and kind of the vector the vector of collision, and just to use those with P5's vector objects using a bit of normalization. Normalization, is that what you call it? Normalizing them. Storing certain values so you're not using them, trying to use them twice. And this little, I've called it my Pauli exclusion algorithm for just subtracting. Let me show you that again. If you've got two objects, this will apply not just for snooker, but any kind of simulation or game or animation where you've got collision. You don't want your objects to overlap and create strange behavior. Once you've decided that they're overlapping, then just slide one of the objects backwards, or both of them, and you could be really clever and kind of get them exactly at the point of contact. Or like me, just by a small amount every frame, so kind of not overlapping, and just hope that your frame rate's fast enough to not cause you any problems. That's what I've done there. What was I just doing? Oh yeah, I was just taking this back to 0.5. Did I try this out? I can't remember if I ran it. I don't think I did. So I'm just going to run this, and hopefully we won't get that kind of momentum problem. Now they look a little sluggish. Look a little sluggish. I don't know. Maybe that's an improvement. I've got a bit of lag as well. Oh, a lot of lag there. Okay. Anyway, the code for this, I'll put it in the description. I'm deploying it on CodePen. I might put it on my site as well, so you can play around and change it and fork it. Don't try and even improve the color scheme here. You're not going to get any better than this. Good luck. What was that? Is that all I want to say? Was that it? Yeah, there we go. We've sunk the cue ball again. Oh, that was it. That was what was in the back of my mind. Last video there was a bug, and a really important one, with a simple fix. So if we go back to the main program, we're in our draw loop. So this is our game loop or animation loop. In there, we've got a for loop, which we shouldn't have there. We should give it its own function. But there we're just going over all of the snooker balls, and we're starting with the last ball in our array. So we've got an array called balls, and we start at the last ball and go to the first ball in the array. And we do it backwards because right at the end of that for loop, we're checking for pocket collisions. So each of the pockets is in an array called pockets, and what we do here is in this nested loop, so we've got a for loop within inside the for loop, we just iterate over all of the pockets, and then each of those pockets checks to see whether we've sunk the ball in question. So the current indexed or referenced ball. Now what was happening, everything was going fine until we spliced or removed, I think it was the last ball from our array. And what happens there is that we remove the last ball, we then try to go around this pockets for loop again, and during that iteration we try to refer to the ball that we just removed from the array. So that's all that was happening, a classic for loop array kind of bug. And so to stop that, I think I mentioned that I was going to do something like that. I just use a break. So all I'm saying is that I'm assuming that the ball is not sunk, so sunk equals false. Then if it gets spliced, i.e. it gets removed, sorry, haven't highlighted the right bit. If it gets removed from that array, spliced from the array, You switch sunk to true. If sunk is true, then break. Stop checking pockets or whatever, so we don't try to reference a ball that no longer exists. Last little thing, you may not have seen this. Instance of. It's an operator, so use like less than or greater than. So use it in the same place as less than or greater than. All I'm doing there is saying if the ball is a cue ball, so that's an object that I created. So that's a way to check, and you might want to do this if you're using classes, ES6 and stuff. If you want to check whether an object is a certain type of object, you can use instance of, just in case you were wondering about that. Right, I let this video go on far too long. Thank you very much. Oh, I might make another video to show you how to do the kind of the queue mechanism, if you like. I don't know. Right, have a nice evening. Goodbye.